Sorry. So, Gabe Stocco. I'm the program manager for TPM. Device Security and Windows organization. This is Scott Anderson from Microsoft as well. He'll introduce himself more specifically. And Suhas is kind of hiding over there. Okay, so we're going to talk about the Windows 10 requirements for TPM, HVCI, and Secure Boot. This slide is kind of pointless, but kind of lays out the direction we'll go in and the order. We'll start with TPM, go to Device Guard, Secure Boot, and then have questions if you have questions. So in Windows 10, we have a number of new features that will be enabled by properly configured TPM. By that we mean a TPM 2.0 device with an EK cert, which supports the HMAC command, as well as SHA-256 PCR logs. So some of these new TPM requirements are the TPM is required on all mobile systems. On a client system, if there's a firmware TPM, it has to be enabled and available to the device. The firmware TPM, so if there's a firmware TPM, you can also use a discrete TPM to meet that requirement instead. After 365 days after Windows 10 launches, you will have to have a TPM in every Windows device except for server SKU. So what happens if you have more than one TPM? So if a customer desire is for a DTPM that's, say, FIP certified, because FTPMs are not going to get certified, you are allowed to ship that other TPM, and that may be the default TPM, but you have to provide a mechanism to both toggle the TPMs and to disable TPMs entirely. Note that if you toggle a TPM, BitLocker will go into recovery mode if the toggle is exclusively through the UEFI interface, and so you may want to provide a warning to the user if they have BitLocker enabled to suspend it before doing so. And also, they will lose all of their TPM stored keys. So, for example, virtual smart card, NGC keys, health attestation keys, that kind of stuff. The other thing we are trying to crack down on is correct PCR and consistent PCR value measurement. This is not something that we've expressed in the requirements more specifically, but it is something to keep in mind to really focus on the correct measurements into the PCR registers, particularly PCR 7, 2, and we'd like to see more consistency in PCR 0 as well. And so as for the motivation for these requirements, specifically the coolest feature is, I don't know if you guys have heard of Windows Hello or Windows Next Generation Credentials. It's been announced as part of the FIDO Alliance, so it's basically passwordless login. The TPM device on your machine will store all of your secure encryption keys. You go to a website, it'll automatically log you in after you do the initial handshake to set up with the website. And those keys then will be protected by a PIN that you set up, or your iris or your fingerprint. And after you unlock the PIN container, the TPM keys can be loaded in the TPM and used to authenticate you with services. Okay. So yeah, I think I actually covered these already. And so we're aiming to really enable high security applications out of the box. We want all of the we want health attestation so that you can validate that a machine is secure before you join it to a domain. We want this passwordless login so people don't have to have, or people don't lose their passwords. The database of public keys that's available on a server is useless for compromising your logins at other websites. So when your user account is inevitably hacked for the 50th time and they're offering you that 1 year of useless identity theft protection, you don't have to worry about your password being used on other sites. And now Scott will talk about Device Guard.
All right. Okay. So device guard, I'll go into the next slide, which gives a little bit of an overview. We will have time for questions at the end, but if you want to throw any out there, that's fine also. So device guard overview. Device guard is sort of an umbrella term we're using for marketing purposes to talk about a set of features that really locks down a Windows system to a particular configuration. So that includes hardware security aspects. It includes something called configurable code integrity, which I'll talk about later, but that allows you to configure, for example, what drivers are trusted, and also turn on something called user mode code integrity, which controls what can run even in user mode, the same way that code integrity controls what runs in kernel today. It includes our virtualization-based security services, which I'll go into more. And that has a direct impact on UEFI runtime services and driver implementations. Basically, when you have a locked-down device guard system, it's meant to protect the OS against admin and kernel-level malware. So even something that gets into kernel, the virtualization-based security provides you a way to protect the system from that. And we have manageability via normal Windows mechanisms, group policy, MDM, PowerShell. You guys probably don't care too much. Okay, so virtualization-based security provides a new trust boundary for system software. So basically, we're leveraging the hypervisor, which today provides a strong boundary between guest VMs on a system, so that one guest can't either corrupt the host, even if you completely compromise that guest, or get any kind of access to other guests on the system. That's super strong security that has hardware assist also. And I'll diagram this in a second, but we're setting up essentially a secure environment to run particular Windows services. The three services that we're enabling out of the box in Windows 10 are LSA credential isolation. So this is to prevent things like the pass the hash attacks, basically credential theft that happens out of Windows that allow people to elevate their privileges and spread across networks. The virtual TPM, that is a server-only functionality that will allow us to have encrypted VMs on servers using BitLocker. And kernel mode code integrity, which is what I'll go into more here. We often refer to kernel mode code integrity protected by the virtualization-based security services as HVCI, hypervisor protected code integrity. All right, so here's a diagram. Traditionally, you see the box in this normal world. We have user mode above the line and kernel mode below the line. And traditionally, kernel mode code integrity protects anything that runs in kernel needs to be first validated by kernel mode code integrity. So the signature on it needs to be validated. But that's happening within the kernel itself. So anything that can get into kernel, corrupt kernel memory, etc., basically has the same powers as the kernel mode code integrity to control what can run in the system, and can even turn off kernel mode code integrity, essentially. So we say, if the malware can get in there somehow, we say, howdy Pierre, and from then on he can do whatever he wants, download more malware. So all he needs is that foothold inside the system. With kernel mode code integrity with Windows 10 and virtualization-based protection, we're adding hypervisor in between, and you see the two red lines, and those are giving us hardened boundaries. There's a little bit of background. Traditionally, the hypervisor has considered the host OS. So in Windows Hyper-V, we have something called the host OS, then you have all the guest VMs. And that host OS has never been sort of considered a threat to the hypervisor. So we harden that boundary, the up and down, between the hypervisor and the host OS. And then we also, what I'm really talking about here is around that secure world portion. We harden that boundary from the normal world. So below the dotted line, the black dotted line, is kernel, even if something gets into kernel in the, and this is all measured into the TPM, even if something gets into kernel in, within Windows, it's not going to be able to impact the kernel mode code integrity protection. So everything that wants to be marked as executable inside the normal world kernel has to come through the hypervisor protected secure world to check on that. So, this means that the code integrity rules are still enforced even if you have a vulnerability that allows unauthorized access to kernel mode memory. But there's implications for drivers and also UFI runtime services. Specifically, memory can never be both writable and executable within kernel, and you cannot change the writable or executable bits directly from within the kernel. You need to go through the code integrity calls into the hypervisor protected code integrity mechanism. So that impacts drivers and runtime services, because traditionally runtime services, I'll just go back to this slide for a second. Traditionally, like I said, if you're in kernel, you've been able to do whatever you want. Allocate new memory, load in additional executable code, or even do dynamic code generation or whatever else you want to do. Having this protection means that anything running, where that malware is, and that would normally include the UFI runtime services in terms of how the memory is allocated, cannot have writable and executable sections. The other thing it means is you need to be sort of page aligned, and you need to mark your pages as either writable if they're actual data, or executable only with NX if they're actually code. So we have some, there's a new thing in the UEFI 2.5 spec. It's not actually a hard requirement for threshold, so for Windows 10. What we're doing in Windows 10, and we consider this a workaround, so we definitely expect to phase this out over time, so this will become a requirement on the UFI runtime services, is if you don't have that memory protection bit set, we're essentially allowing you to run in the same memory address space as the secure stuff, which means any vulnerabilities you have can, compromise our security, and we would be very unhappy about. Really, this is a subset of the stuff that Dick was just talking about. We'd like to see the memory protections across the board. This is saying this one specific area without those memory protections, and we don't have good compatibility with runtime services. So when we talk about hardware security, what we're really saying is that someone, even with physical possession of a particular device, cannot easily own that device. So it includes things like platform secure boot. So even before we get to UEFI secure boot, that right from the initialization of the chip, you're only running trusted code. Includes things like secure firmware updates. If people have this type of device, you should have no physical way to override the normal signature checks that you do to install firmware. Includes locking the BIOS menus. So if you want sort of a device guard compatible system, if I'm saying that the owner of this device cannot easily, or so I shouldn't say the owner, the person who has this device, who's been issued this device for their company, cannot easily override the BIOS protections like secure boot, or turning off secure boot, changing the DB, booting from different media that might not be secure. All that needs to be locked down, which means they're not going to have access to the BIOS. So we're working with a variety of OEMs. If you look at the link to Device Guard, you'll see we've posted some graphics from a handful of OEMs that are planning to have Device Guard ready devices. So they'll likely be talking to you about making sure they can configure their BIOS in such a way that it supports these features. So all up, device guard ready machines, it means that you have virtualization extensions on by default. We know some people ship devices with the virtualization extensions off, and you need to go into BIOS and turn them on. Obviously, if a company is deploying this, they don't want users or even the IT staff to have to touch machines, go into BIOS to turn on the virtualization. UEFI runtime services that are compatible with HPCI. Today, that's not a firm requirement because of the workaround I mentioned before, but we really want to see that memory protection stuff added. Andrew from our kernel boot team is here to either discuss with you, or even he's brought some private bits of our implementation if anybody wants to test with us this afternoon. And the BIOS lockdown, as I already mentioned, around what are the boot options, enforcing Secure Boot Beyond, and exactly what can boot with Secure Boot on, and securing firmware updates. And that's it for device guard. Is there a question? Yeah. It's probably a better question for one of the other dozens of people in this room. I think what we've seen actually is just not necessarily that there's particular calls, but just because nobody's paid attention to this, you have mixed data and code sections, so nobody's ever tried to sort of align their sections and mark the data as data only and writable, and the code as execute only and not writable. So I think it's more just a hygiene issue that nobody's thought of doing this before, or taking the time to keep those things separate. I don't know that there's I don't think there's any dynamic code generation happening that you'd actually need to have that.
That's the runtime part.
Yeah. Right, yes. Yeah. Yeah, so like I said, this is a subset of what Dick was talking about. We'd also love to see all the memory protections during boot, not just runtime services, and in SMM, because SMM is obviously a whole other memory space. But just in terms of purely for this compatibility, we need it for the runtime services. Yeah?
So what's the impact of DMA devices with PCI?
So one of the things you can do is turn on the IOMMU.
Is that a requirement, or is that?
We actually debated how hard a requirement to make that. So right now you can configure IOMMU on or off just because, to maximize compatibility. So it's definitely a strong recommendation that you have IOMM turned on, but we do allow you to run with it turned off. Yes. Yeah. So the baseboard management controllers are basically you're underneath the operating system and you can reconfigure. And the idea there is that that's owned by the enterprise, right? Not the person who they physically deployed a machine to. And I talk about physically deployed machines and point to this one like it's a laptop. That's certainly one scenario. But really, we're also talking about these sort of fixed workloads. We're talking about cash registers. We're talking about specific devices that have a very well-known workload if you're going to lock them down to this degree. I talked about part of this, which is less relevant to you guys, but is turning on what we call user mode code integrity. So that's everything that runs in Windows on the desktop needs to be signed by a trusted signer. The enterprise can set up who they trust as a signer. So it's similar to the technology we have, say, in the phone, but in that case we only trust things that are part of the phone OS that comes from Microsoft. But this allows an enterprise to control all of that. So, if you're going to that lockdown mechanism, this isn't sort of the regular information worker, or it's definitely not a bring your own device scenario, right? This is a fixed, well-known workload of a managed system. Yeah.
One question is, you have a hypervisor installed with the hardware because hardware virtualization features. So essentially, we have an environment which is a VMware, and you need to install your Windows 10. What happens then? Hypervisor on top of another hypervisor?
So the question's around if you're using like VMware or something and nested virtualization essentially. So yeah, Hyper-V doesn't directly support nested virtualization today. This is an opt-in feature, so you're not like anybody just deploying Windows 10 in standard configuration, this does not get turned on, right? You need to either order a machine that's ready for that or, enable it on purpose. Anyways, we do have some time for questions at the end, and we'll be around after, so I should probably let Suhas finish up the presentation so we don't run over. Thanks.
Thank you, Scott. Yeah, our next few slides will go through about Secure Boot and few other important things that doesn't fit really in with the bigger topics, but we'll call out and go just to make sure that everybody's on the same page and we have open discussions on those. There have been a couple of additions in Windows requirements document over to 8.1. These are the two big ones, or most likely in Secure Boot, these are the only two ones that we can go and be on the same page. First one is HSTI. We have been talking about HSTI, which is basically a hardware security test interface for over 2 years now. We did have a detailed presentation on this in last UFI Summit last year, same UFI Plugfest, where Jeremiah did go over in detail of the value prop and what needs to be done to support HSTI, etc. With Windows 10, this is becoming a reality. This is a requirement to ship Windows 10 mobile devices and connected standby devices. We've been working with all the partners that needs to contribute in to make this work, and we are at a good stage where we can go out with HSTI working correctly and being effective, catching all the unsecured, incorrectly configured devices before devices ship out. We do have a HLK test. Recently, a UI for this in HLK test did go out. Otherwise, the command line HLK test did exist for like a couple of weeks. We have Jeremiah here in case if you have systems that you want to test out for HSTI. We do have HLK test in the EAP builds as well, if you want to try it on your own. The second one is Microsoft UFI CA. We do know about UFI CA for long since the start of UFI itself, but we never really called out explicitly on Microsoft UFI CA in the requirement documents. That led to some confusion, not really understanding should systems be shipped with UFI CA or not. To make sure we don't have that ambiguity, we have articulated requiring Microsoft UFI CA in the requirement documents. With UFI CA comes the need to have up-to-date DBX being shipped out of the box. For last over 2 years, we have shipped DBX updates for I think like twice or thrice, give or take. But yeah, in an average, you can consider we revoke things once in. Thank you, Peter. We do revoke things once in a year, say. I mean, this is not a guaranteed one depending on the needs, but in an average, you can consider it so once in a year or two. But we do request OEMs to update these DBX as soon as they come out, so that OEM ship devices secure out of the box than waiting for Windows Update to kick in and take care of it. Yeah.
What happens if an OEM ships with an up-to-date DBX and then, say, later that year, a new DBX is released?
Windows Update will take care of updating DBX. DBX can be updated by firmware, by DBX update that comes through Microsoft, basically through the KK signed by Microsoft.
Well, what's Microsoft's recommendation on system firmware picking up DBX updates and firmware releases? And should the device automatically update the DBX after the firmware is upgraded?
Yeah, we do have a slide to cover firmware update through Windows Update. We'll come to that. But for DB and DBX updates in particular, we already have a solution in place. You can use, since mostly this DBX revocation is driven by Microsoft, since we offer UFI CA. So this is mostly driven by us, and OEMs most likely won't be aware of this unless it really goes out. Having said that, if you have your own DBX, if OEMs have their own DBX revocation that they need to do, for example, if they have included few other certificates in DB, that they own, and they need to, if they have to ship out update for those, sure, you can use firmware update through Ubuntu. But for revoking things that are signed by UFCA, we already have a pipeline in place which works, and we can use the same one. We'll come to the firmware update through Windows Update in a little while, but yeah, there is a pipeline in place that Microsoft uses to revoke things which we used like a couple of times in the last 3 years. With clearly articulating need of UFCA in requirements document, we do need to have OEMs to make sure that they ship up-to-date DBX right out of the factory so that machines out of the box are secure. We do have HLK test for this, this has been in the HLK for a couple of weeks now, and if you have hit any blockers using this, do let us know, and we can figure out what you can do. To give you a brief overview of HSTI, it's been few months we have put it on MSDN so that we don't need to put it on Connect and discuss in Microsoft NDA, but we can be more open and make progress here at a much larger scale than constraining our conversation to just Microsoft NDA or UFI NDA. Basically, HSTI is you can pursue HSTI as not as a requirement, but opportunity for IHVs and IBVs, and sure for OEMs as well, to make sure that you got the configurations right before you ship devices. As of today, one of the major things that are used is HLK. HLK is basically our new terminology for what we had called HCK before, hardware certification kit. It's rebranded, but yeah, practically it's the same thing. That's one of the main QA that OEMs might do, but that won't be enough for most of the BIOS and UFI related stuff. So having HSTI and taking that opportunity to make sure that you get the configuration right would be a big step towards securing the platform before the ship. So please do not pursue this as a requirement, but this is an opportunity to get things right. And yeah, you can make sure the whole pipeline is doing the right things than concentrating on individual pieces, either be just HVs or IBVs or OEMs. This is pretty much about HSTI, and we do have time towards the end to discuss in detail or take questions if you have anything to talk about this in detail. Then UFCA that's offering the service to assign all third-party UFI components that needs interoperability. Again, we have been making significant investments in this to give better turnaround time and better security. And we have been rolling out few policy updates as and when we realize something that is missing or something that would benefit by making an update. That's the link which has up-to-date policy details, and that keeps getting updated, and whenever it gets updated, we generally send out emails to all UFI submitters so that they're aware of that. Big 3 points to call out is no organization-only, OEM-only, internal tones-only products. If you think your product needs to run on every UFI machine out there, then you need to get it signed by UFCA. Otherwise, we recommend for OEM or internal organization only or internal tunes only, self-sign your component and add the certificate or hash in the DB, and you're good to go. And there's there is a link in that link which details out to a pre-submission testing guideline that has ways, also a sample CA that you can use to sign your products and add it to the DB. And second point is RTM product only. It's kind of continuation of the first point. If you don't think your product will be used by every user out, or available to be used by every user out there, and if it's not RTM product, then you don't need to be signed by UFCA. You can self-sign and put the certificate in your DB and test it and use it internally even for beta testing or alpha testing. Third one is mainly related to the way we see Secure Boot and end of Secure Boot and what exactly is our responsibility and what exactly is developer's responsibility. Basically, if your product can be used by any means to bypass secure boot, then it's your responsibility to fix it. It doesn't matter in which chain that's happening, but if your product is being used, then we will revoke your product. So it's your responsibility to make sure that your product cannot be used to bypass secure boot, irrespective of at which point in the pipeline it happens. If folks are interested, we can have an open discussion and brainstorm session to figure out how best we can provide better turnaround time without compromising security. We have an adjacent room booked for 4 to 5. The one Dick mentioned, right next to this. So if folks are interested, we can have the discussion and figure out what best we can do. Do you guys want to have one? Like, can I get a quick survey of who would like to be interested in the discussion? Okay. We have enough interest. I think we'll go ahead with 4 to 5 next room, and we can have an open discussion about what we can do to give better turnaround time without compromising security of the secure boot pipeline. And yeah. Few other important things that didn't fit in any of the 3 presentations, but is important to call out and go over. The first one is remote attestation. This is part of new server host guardian service. We do have Cheng Wang from remote attestation team. In case if you have more questions on this or want to have an offline conversation post to this presentation, or if you can't cover through in QA session, he's in the center table there. Yeah. Basically, this is a service applications or OS components can make use of to establish to establish the identity of the machine and then take dependency on that. This feature mainly does 2 things: validates host identity and host configuration, and then it issues a attestation certificate to validate the host, and you can take dependency on that. For host validation, these are the 3 components that it looks for, and we'll in next slide we'll go in detail in what is required to be done by the OEMs, IBVs, and IHVs to support these things. First one is host identity validation. Basically, it takes dependency on TPM EKPub. For the second one, host configuration validation, it's basically kind of TPM measurements and measurement based of things. Known good TPM measurements, consistent TCG logs, and known good HVCI policy hash. It's the same HVCI that Scott talked about. Host UFI validation, this is based on known good DBDBX, and we do have a new section in Windows requirement documents which talks about this. It's part of its title is Server Assurance AQ requirements. Basically, this is based off TPM 2.0 client, TPM 2.0 and Secure Boot client requirements. In addition to that, there are a couple of management-related requirements that will help manage remotely multiple servers at once than being physically present to do the same. The first 3 are mandatory. First 2 are mandatory in TPM 2.0 client that we are all familiar with. Third one is automated tool to provide remote management to say either take ownership of TPM or clear TPM, and there is optional PPI clear settings which can be set depending on your customer requirements, and again automated way to manage it if asked for by your customer. Then for Secure Boot, it's exactly same as what is for clients, except for second management ability to be available so that remote management can happen, and this feature should still work. We all did see UFI 2.5 come out, and a lot of folks, pretty much everybody in the room did contribute to get 2.5 out the door, and it's been really good. It has really good updates and a good step forward. A few other things that we want to call out, we as in Microsoft want to call out from 2.5 that are relevant to Secure Boot and around. First one is based on Mantis 1224 physical memory protection attribute. Scott did talk about this and for the HVCI section. This is needed for HVCI and Windows 10, but we do have a workaround for now, but this will be a requirement in next OS release whenever that comes out. But if you if not decided and if you are planning to implement, then please do go ahead with 1.2.24. That will be used for Windows 10 and will be needed anyway. But we do have a workaround in case if you can't get to that now. Second and third. Second is basically platform recovery. That's Mantis 1.2.27. Currently, we don't have OS support in Windows 10, but we are very much hopeful to have the support in the next version of the OS release. Strong recommendation is not to implement this unless at least one OS vendor supports it. Otherwise, without having right SCT test or HLK test, if you get this wrong, a messy firmware will sit there for next 10 years and there's nothing we can do about it unless you guys also plan to implement firmware updates, hopefully through Windows Update. The next one is customized deployment of Secure Boot. This is also a big win in UEFI Spec 2.5. Having said that, we don't have Windows 10 OS support for this just yet, but we are very much hopeful to support this in the next OS version. Again, please do not implement this unless at least one OS vendor supports it. Again, if without having proper tests in place, if we roll this out and later find bugs or security issues, then the hardware will not be usable for whatever features that take dependency on this. And this one being a critical and customized deployment of Secure, basically, which means you would ship devices in an open state and it's OS responsibility to lock it. And if OS doesn't support it and doesn't know how to lock it, then firmware will be open for malware to attack. So the third one is critical. So please do not implement it unless if one OS vendor supports it. And Windows 10 plans to do it in the very next release we will get to. This is the last slide about firmware update review. We did have a detailed presentation about this during our last UEFI Plug Fest. Back then it was not open for everybody, but we were collaborating with few OEMs to get this done right, to get the pipeline done right. Now it's open to all OEMs. So anybody who wants to try this, please do reach out to the folks listed here. We also have MSDN documentation for this too, which covers in detail what you need to do to get this. And the presentation from Plug Fest is also included in case if you want to take a look at that. I think that was the last slide from this presentation. We do have some time and we can open up the floor for Q&A. But before opening up the floor, I do want to introduce folks from Microsoft related to this that you can follow up offline or later if we can't get through all the questions during QA. We have Scott, Gabe that already gave a presentation. We have Jeremiah for all the HLK and generally for everything related to UEFI. And we do have Cheng Wang for remote attestation and Andrew Harper for HVCI and related things. In case if we can't get through all the questions, we can sync offline and you can get hold of any of them for HLK tests that are listed here that are available for Windows 10. I think we can go with Q&As if you have any.